Hi everyone, my name is Chris Kahn and I'm going to be doing a brief introduction today to what is a blockchain. So let's start by just defining a blockchain. So what is a blockchain? So by definition, it is a chain of blocks. However, what is in these blocks and why are they chained together? So the first popular use of a blockchain, as you most likely know, is Bitcoin. So Bitcoin was created a little more than a decade ago, and the way that Bitcoin meant to secure the network and also preserve the integrity of all the transactions on the network and have this sort of audit trail of every transaction that's ever occurred is through the use of something called a blockchain. So in the Bitcoin white paper, they never actually mentioned the word blockchain. The phrase is actually a chain of blocks, and every block is essentially a finite number of transactions that are batched together and confirmed at the same time by miners in the network. And we'll get into mining in a little while and why it's important, and how different types of blockchains achieve consensus. So once a certain number of transactions are confirmed in a block, then a new block is started. And depending on the blockchain, blocks can be of different sizes, they can have different numbers of transactions. And when I say different sizes, I literally mean the amount of kilobytes that go into a block. And of course, if you want to create more and more complex transactions, these blocks get bigger, and you're essentially bidding auction style for space in these blocks. So the cost to submit certain types of transactions can be higher or lower depending on what you're trying to do and depending on the blockchain. So with a blockchain, and again, just using Bitcoin as an example, after a block is confirmed, a hash of that block, so basically a summary, I'm sure you all know what a hash is appended to the top of the next block. So that's how the blocks are chained together. And essentially, when a block is confirmed, a hash of that block is included in the next block. And that again just preserves the integrity of the network. So, what are blockchains used for? What are some examples? I'll move on to the next slide. So we've just talked about Bitcoin. I'm fairly certain everybody knows what Bitcoin is. You might have some, you might not have some. You may have your own views on Bitcoin, but there are a bunch of different blockchains that all do different things or different permutations of the same things in different ways. So the most popular I've listed here, in my opinion, or I guess kind of categorically, Bitcoin and Ethereum are the most popular by market cap and by usage. But some of the other sort of high profile ones include Avalanche, Solana, and of course Nervos. And I'm not going to talk too much specifically about Nervos because one of my colleagues is going to be doing a different session on that. So how are these blockchains different? So Bitcoin was created to be peer-to-peer cash. Now, depending on who you ask and depending on the day of the week that you catch them, this definition changes pretty drastically. So the original concept of Bitcoin was peer-to-peer digital cash that's censorship resistant and no one can stop it or tamper with it, and it's completely open and permissionless for everybody to use. Ethereum's a little different. So Ethereum was created kind of out of Bitcoin. The Ethereum team, many of them were actually involved in Bitcoin early on, and Vitalik, the creator of Ethereum, actually had a Bitcoin magazine back in the day. And Ethereum was created out of a need to do things that Bitcoin could not do. So just like Bitcoin, it's a proof of work blockchain, though that may eventually change. And again, we'll get into proof of work in a little while. But unlike Bitcoin, as opposed to just being peer-to-peer digital cash, Ethereum is a blockchain that allows you to execute pretty much, I shouldn't say any, but a pretty large variety of technological computation and transactions that involve multiple parties cooperating together. So this uses a technique called smart contracts. In the coding world, you'll appreciate that smart contracts are neither smart nor are they contracts. Smart contracts are basically just lines of code that execute when certain criteria are met. So the simplest example of a smart contract can be, if this, then that. So if a third party Oracle, a third party data source has dictated that a certain team has won a certain football match, then money can be moved from wallet A to wallet B. That's an example of a smart contract. You can use smart contracts for pretty much an unlimited level of complexity. So you can use it for the example I just gave, which was betting. You can use it for insurance. You can use it to create complex trading transactions, including leverage, including margin, including collateral. And we'll get into some of these things. I know I don't have a whole lot of time, but I want to give you a little bit of a flavor for what some of these things that you can actually do are. So why are these chains different? So it boils down to their token, their consensus mechanism, their purpose. So again, Bitcoin is digital cash, or depending on who you ask today, it's a store of value. So think of it like digital gold. Ethereum is, you can think of Ether, the unit of currency on Ethereum, as digital oil. So as opposed to digital gold, where you kind of just like hold it and look at it and it's pretty. Digital oil, Ether can be used in a way where you're actually powering different applications, and that's why it's like oil. And the price of oil kind of goes up and down based on how many people happen to be driving cars and flying airplanes. And just like that, the price of gas on Ethereum will go up and down. You can look at Avalanche, which is different than Ethereum in a lot of ways. It's proof of stake, so the consensus mechanism is different, and we'll get into that later. But it's meant to do a lot of the same things. So you can write smart contracts on Avalanche. There are parts of Avalanche that are very similar to Ethereum. They use some of the same tools and some of the same applications. Can be used on either chain. Solana is very different. It's not compatible with the Ethereum virtual machine. The fees are very, very low, and there are many people in the community who don't believe that Solana is actually fully decentralized. And we can get into in a little bit what decentralization means and why it matters. And then Nervos, again, I won't take thunder away from my colleague who's going to talk about Nervos in a little bit, but it's very, very different than everything else out there. And we think we're really solving a very big pain point that other chains don't solve. So why are some of these blockchains cheaper to use than others? I mean, there's a bunch of reasons. So if you look at Binance Smart Chain, the fees are pretty much non-existent because Binance is running all of the nodes and they don't really need to make money off of fees. They're running the nodes at a loss, and basically because Binance Smart Chain is centralized, it's and by definition, is it really a blockchain? I guess it really depends on your definition. But because of that, fees are very low. They don't need to crank fees up. But if you want decentralization and you want strong security, then the fees are going to be higher, right? You get what you pay for. And that rings true with pretty much every facet of life, especially in this space. Why does every chain have its own token? So a token, and we'll talk about this when we talk about mining, a token is vital for the security of the network. It's vital to incentivize the security of the network. So we'll go on to the next slide. So what are some main characteristics of blockchains? Again, it depends on who you ask, but I think this is a pretty good list of what every blockchain is going to at least aim to have. So the first one is it has to be decentralized, right? All blockchains need decentralization. It needs to be open. There's no such thing as a closed blockchain. It doesn't make sense at that point. It's just another permission system that every large corporation in the world is using. You need distributed consensus. You need immutability, and I put it in quotes because it's just kind of a buzzword people have been throwing around for years. Basically, you want an audit trail on a blockchain. The idea is anyone should be able to run a node, anyone should be able to see the entire transaction history of the blockchain. And then the last two are kind of interrelated. Blockchains are meant to be a secure system, secure way to interact, and they almost always use some type of public-private key cryptography, which I'm sure many of you are familiar with. Essentially, you have a public key that you can share with whomever, and it allows you to receive funds. But if you want to send funds or initiate a transaction using your wallet, then you need your private key, which obviously you keep private. So what are some applications? I'll go to the next slide of blockchain. So we've already talked about peer-to-peer cash. One I want to talk about a little bit later and give some examples for is decentralized finance. You can also use them for identity verification using the public-private key cryptography that I just outlined. And then I put another one in quotes. I put enterprise blockchain. So there's this big sort of, movement that, to my dismay, still has not died out. But basically, for the past 7-8 years, a lot of large corporates, especially banks and companies that kind of run the risk of being disintermediated with this type of technology, they've thought that, we can harness the technology, right? We can harness the technology of the blockchain and not use any tokens, and we can do all these magical things. And essentially, the jury has spoken, and this is utter nonsense. There's no such thing as an enterprise blockchain. This goes back to my point on the last slide about blockchains needing to be open and permissionless. Anyone should be able to run a node. Anyone should be able to participate, send and receive funds, create transactions, view the transaction history. If there's a mining mechanism, which we'll get to in just a second, they need to be able to participate in mining. There's a whole bunch of things that you need to be able to do. And all an enterprise blockchain is just a fancy SQL database that runs on a couple of different machines. And there's nothing wrong with that, right? It's totally fine to do that. Companies need that. Companies need private databases. But you don't need to call it a blockchain, right? You don't need to use a blockchain for everything. And I've been saying this for years, and if any of you happen to know me, you've probably heard this before, but using a blockchain for every possible application is like taking a Hummer to the grocery store, right? You can take a Hummer to the grocery store, but with gas prices as high as they are, I don't think you want to. You don't need to take this huge truck to the grocery store just to pick up a bag of milk and a bag of eggs. And I think that's what a lot of companies are realizing now that they've been doing for the last 8 years is kind of futile. So on to the next slide. I want to talk about mining a little bit. So I alluded to it a little bit before, and I know I'm kind of pushing right through these examples, and we do have a lot of ground to cover. So mining is a mechanism that incentivizes network security by paying users for either their computing power or for something else. So there's two types of main consensus mechanisms that I'll cover. There's obviously an infinite number of consensus mechanisms, but the most popular are proof of work and proof of stake. So Bitcoin and Ethereum currently run on proof of work. So does Nervos. Um, Avalanche runs on proof of stake, and Ethereum is moving to proof of stake. They recently, just a couple of days ago, actually um, made the testnet, the Ropsten testnet, run on proof of stake, which they're referring to as the merge. And this would be a really big development, and a lot of environmental activists or people who pretend to be environmental activists talk about how proof of work is so, unenvironmentally friendly. But let's talk about what proof of work is. So proof of work is a process by which you are using computing power, and the press kind of gets it wrong. They say you're solving a complex a complex mathematical equation. You're actually not solving an equation at all. You're basically doing something that is intentionally designed to be wasteful work that you can't use for anything else. It's not like you're solving unsolved mathematical problems from the early 20th century that no one's figured out using all this computing power. You're literally doing throwaway mathematics. And the reason you're doing that is because one would think no logical person would waste these expensive computing resources and then lie about the veracity, the truthfulness of a block. So basically what you're doing is you're running a reverse hash, and we don't need to get into the specifics of how this works. If you're curious, I encourage you to look into it because it is actually pretty interesting. You're basically trying, so a hash is a one-way function. If you have something that's one letter long or 2 letters long or an entire book, you can have the text of Ulysses. And if you hash it, you should always, and I mean, you will always, with SHA-256, you'll always get a different output. What proof of work does in many cases is you're trying to reverse a hash. So you're running a bunch of hashes on a bunch of different numbers and you're trying to get the same output. But because that's impossible, you're not getting the same output, you're just getting the first few characters. Basically, you want to get a bunch of leading zeros so that the hash is less than the block height. And again, we don't need to get into that, in too much more detail. But you're basically doing throwaway, useless math that's very computationally expensive. If you are the first to do this, then you can propose what the next block looks like, and then you're basically, through the rest of this process, you're compensated for doing this. So it's very expensive to do this, but you are compensated pretty handsomely by the Bitcoin network to the tune of hundreds of thousands of dollars per block. So it makes a pretty big uh, economy for this kind of stuff, and that's why people put so much computing power towards doing this. Now, proof of stake is a little different. As opposed to using your computing resources, and then if you're, you know, wrong or lying or however you want to say it, you lose those computing resources, which means you're kind of losing time, money, and obviously depending on your energy cost, that money, energy cost will be the highest one. With proof of stake, you're actually staking coins. You're saying, I'm staking these coins, and I'm saying, with these coins on the line, I'm saying that this is the true state of the network. I'm saying that this block is accurate, these transactions occurred, and I'm staking these coins. And if a bunch of other people, are voting on a different state of the network, and you're outvoted, and of course, you're probably thinking game theory doesn't make sense for people to do this, doesn't make sense for people to lie. We can debate that for a very long time. But essentially, you stake these coins, and if it turns out you were telling the truth about the network and everyone is in agreement, then you are compensated for staking these coins. And that's another way of mining. So there's a bunch of other consensus mechanisms out there. A lot of advocates of proof of work say that proof of stake isn't decentralized enough and it's not secure enough. And then a lot of advocates of proof of stake say proof of work is not environmentally friendly, though I kind of roll my eyes at these people because a lot of these people are not the kind of people who care about the environment, so they're kind of just poking holes in something that they don't agree with. So now that's all introductory basics of what a blockchain is, right? We talked about consensus in mining. We talked about decentralization. We talked about immutability and having this sort of open ledger of transactions. But what are the main applications on a blockchain? What are people actually using them for today? So I'll go to the next slide. So there's a bunch of really popular DeFi apps. DeFi, for the uninitiated, stands for decentralized finance. It's far and away the most popular use case of blockchains. And depending on the day, you can talk about NFTs as well, and we can get into those as well, just briefly towards the end. But for the most part, DeFi is kind of where it's at in the blockchain universe. And the reason for that is whether the market's going up or down, people are always going to be using these types of services. So some of the more popular applications for trading, such as Uniswap, SushiSwap, 1inch, these are applications that allow users to swap one currency for another without needing a centralized, trusted third party in the middle. So you're probably familiar with Coinbase or Binance or KuCoin or Gemini. These are centralized exchanges. There's a company that sits in the middle. They're paying market makers. They're taking fees. They are allowing this marketplaces to occur, right? It's like going to the town square and you see a bunch of people with tables selling, bread and cupcakes and things like that. They're there because the city has basically granted them permits to go there and do that. So centralized exchanges are inherently permissioned. So in lots of occasions, you need to submit identity documentation and you need to be verified depending on the jurisdiction you live in to use these services. What these decentralized applications do is very different. They say, we don't care who you are, where you live, how much money you have, you can come in and use our services. So on Uniswap, you can go on and you can swap a million, tens of millions, in some cases even more, of one currency for another without the need for a trusted third party. You don't need to give them an ID, you don't need to give them a bank account, they don't need to know who you are. And there's that famous saying that goes on the internet, nobody knows or cares if you're a refrigerator. And with DeFi, that's true for the most part. Most of these applications that are especially the ones that are purely and truly decentralized, they don't care who you are, where you're from, where you live. You can use the applications for however many millions of dollars you want. So that's trading. Then there's lending applications. So Ava and Compound are some of the more popular ones. When you think of traditional borrowing and lending, you're probably thinking, my bank gives me 0.01% interest on my deposits, but my credit card charges me 25% interest. How does that work? Well, the reason is because there's a centralized party in the middle that's just pocketing all this money, and then they're paying a bunch of people to sit in offices and answer the phone and deal with customer service inquiries. In the decentralized finance world, you don't have these customer support reps and people to basically siphon all this money from you. So you would think that the spread between how much you would pay to borrow and how much you would get to lend should be a lot lower. And in a lot of cases it is. So if you go on these sites and the rates change every day, so there's no use really in doing, and giving you the most recent rates. But if you go on these applications and you go to Aave, you can see that the rates are pretty favorable. You can borrow money for way cheaper than you would with a credit card. And if you want to lend out your money, you'll get way more than you would just leaving it in a bank. And there are lots of other uses for doing this as well. You can use that to do leverage trading. And there's another company just wanted to shout out because we're working with them as well, called Delta Prime, that allows leverage trading in a decentralized manner. So basically, you're borrowing funds and using those funds to make leverage trades. Basically, making trades without having to post margin, without having to post excess collateral. Um, and there's some other applications as well. So there's derivatives, which, if you're familiar with the traditional finance world, derivatives are a huge part of how, the world goes around. A lot of times people are not actually betting on actual things. They're using derivatives. So futures, perpetual swaps, things like that. There's also stable coins, which we can get into in a minute. Then there's privacy applications like Tornado. So Tornado is a really interesting application where You can put funds in using a round number. So with ETH, it's 0.1, 1, 10, or 100. And then you basically wait, and then you can withdraw it using a zero knowledge proof to another wallet, and nobody knows where the funds came from. They all came into a pool with these round amounts, and then they come out in these round amounts. So if you did 123.456, then and then withdrew 123.456, then people would be able to triangulate. But with these round amounts, it's substantially harder to do so. So there are some really valid use cases for these types of applications. So I'm quickly running out of time, so I want to move on. So we'll talk a little bit more about some decentralized exchanges. So some DEXs, such as 1inch, which I mentioned in the last slide, are aggregators. So they shop your trade out to whatever decentralized exchange has the best fee. So, or it has the best slippage. So when you're trading, and I don't want to go into too much detail, but because these are decentralized and you have these liquidity pools, when you're trading a large amount of one coin for another, you might have a high price impact. If there's a pool with $1 million of one token and $1 million of another, and you're trying to swap $1 million of one token for $1 million of another, you simply can't do that. You would eat up the whole pool. You would throw the pool out of sync because the pools always aim to be 50-50. That's kind of the way these things work, and you wouldn't be able to do it. And even for a pool with $1 million on each side, if you're trying to do $100,000 or $200,000 trade, you're going to have a bad time. So a lot of these decentralized exchanges thrive on very large liquidity pools. And people are incentivized for providing liquidity. As you may imagine, they're paid in token, they're paid in trading fees. There's ways to incentivize people to provide liquidity for these trading pairs. So other DEXs offer types of synthetics, like we spoke about before, um, and some of these things you can't find on centralized exchanges. And then there are things that you can find on centralized exchanges, and if you look at for those who are perceptive, you probably noticed there's pictures of Donald Trump on the screen. So there was a token on FTX called Trump 2020, and it would expire to $1 if Trump was reelected in 2020, and then it would expire to zero if he wasn't. And up until a solid, 6 months, 8 months, a year after the election, people were still buying and trading this token at a couple of cents, thinking that maybe somehow he would be declared the actual victor of the 2020 election all these months, or a year later, and the token would expire to $1. And there's already a market for Trump 2024, which is a token that expires to $1 if he's elected in 2024 and expires to zero if he's not elected. And I don't know the price of it today, but if you go on FTX, which is a centralized exchange, um, that is actually something that you could invest in today. But the reason I bring it up is there are some decentralized exchanges that list products that you can't find on centralized exchanges, and that could be because there's not enough liquidity, not enough interest. There's no market makers for it. Because keep in mind, the centralized exchanges, they run because you have this thriving community of buyers and sellers. To use my analogy of the farmers market, if you have a farmers market and it's a cold, rainy day in the middle of nowhere, you could have 100 booths selling iPads for $5 and no one's going to be there to buy it because you're in the middle of nowhere. With centralized exchanges, they thrive because they have this community of buyers and sellers who are KYC'd, meaning that they've submitted identity documentation, they're known participants, they're using the platform, and then you also have market makers and hedgers and people who are providing liquidity in that way. So on to the next slide. So, and very quickly, and this is my last content slide, I just want to talk about borrowing and lending. So like I mentioned before, um, you can deposit funds and borrow funds using applications like Aave and Compound. And if you want to borrow against your stash of crypto, you can do that using something called a collateralized deposition. So basically, you let's say you deposit $1,000 worth of ether. In a lot of cases, you'll be able to borrow 30 or 40% against that. So you can deposit $1,000, you can borrow $300 or $400 worth of stable coins, and you can do with that whatever you want. You can go out and buy more ether. You can do the reverse. You can deposit stable coins, borrow ether, then sell the ether to kind of create like a synthetic short position, betting that the price will go down. And then there's another application called Maker. We alluded to stablecoins just a couple of slides back. Maker is a stablecoin application where you deposit funds into a vault, and then you can create new stablecoins. Stablecoin is called DAI, DAI, and it's a stablecoin that's collateralized by what you put in the vault. And then, of course, as the value of the collateral fluctuates, you have a burden of and this goes for all these products, as the value of your collateral fluctuates, you have the burden of topping up your collateral or paying back the loan, otherwise you'll get liquidated. And getting liquidated means the collateral that you have is not enough to satisfy your outstanding obligation, and they're going to take that collateral from you and sell it, and then you can keep your loan. Um, in a lot of cases, in most cases, you have an incentive to pay back your loans because if you put in $1,000, you're getting $300. So if you don't pay back that 300, you lose 1,000. So you really do have an incentive in most cases to pay back the loan. But think of a market where things have gone down by 70%. Let's say you took a loan out. Let's say you put $1,000 of ETH in. You took out $300 or $400 of USDC, and then you bought something like Avalanche. Let's say Avalanche doubled or tripled. I mean, this is probably not going to happen in the real world. Like Avalanche isn't going to triple while ETH goes down 70%. But let's say Avalanche even doubles and Ether goes down by 50%. Now the amount that you have in Avalanche is worth more in US dollars or euros or whatever than what the ETH collateral would have been worth. So you have an incentive to actually default on the loan and just move on. So you can think of situations where this kind of stuff might happen. And these are, really, really fascinating things that people like me think about all day long. There's an unlimited number of use cases for different applications in the decentralized finance space. And again, far and away, DeFi is the most popular application in the blockchain space. It's what keeps the space moving. Even when the markets are down, people are always looking for ways and opportunities to borrow and lend money because you can borrow money. You don't even need to use it for a crypto purpose. If you have crypto, you might want to borrow money and go out and buy a car, or buy a house, or buy lunch. And the applications that exist today allow you to do a lot of these different things. So that's really it that I had for today. My last slide just says what's next. There's new applications and iterations being made every day, and yeah, we're excited to see what the next couple of years bring. A lot of people say that bear markets are for building. I'm a firm believer in that. You can't try to time the market. You can't only release applications and tokens and products when the market is in the green. When the market is stagnant or going down or just going sideways for a while, it's a great time to build new things and get ready for the next run. So that's it for today. I thank you for your attentiveness. I hope this was at least somewhat useful or exciting for you. And yeah, I really appreciate your time and enjoy the rest of the day.